So we started this problem yesterday. We didn't quite finish it because we got to this point here. We figured out that 16s to the fifth and 54s squared had a greatest common factor of 2s squared. And we factored that out. We did that first. Then, so we started off by factoring out the 2s squared. When we factor that out, we got 8s cubed plus 27s, or 27, this here. And we saw that we could take the cubed root of 8s cubed, and when we did that, we got 2s. We could also take the cubed root of 27, which gave us 3. And this is the part where we kind of stopped off, or we ran out of time. We didn't quite have enough time to finish this problem here. So all we had to do next was to plug in our values. And 2s was our a. So in the first spot, it would have been 2s. Nothing here. Then we would have had 2s squared, 2s to the first, and then nothing. Then our b was 3. So we'd have 3. We wouldn't have anything in this first spot. Then we'd have 3 to the first, and then 3 squared. So we're just filling in this a and b value. Now at this point here, we can simplify a little bit. So our first one would have been 2s plus 3. Now 2s squared, well 2 squared would be 4, and s squared is s squared, minus 2s times 3, well 2 times 3 would give us 6, and our s. And lastly, 3 squared gave us 9. And this is it here. So the one that we didn't finish yesterday ends up, once we plug in our a and b, ends up simplifying down to 2s plus 3 times 4s squared minus 6s plus 9. So this is the one we didn't quite finish the other day. Now, we're going to look at 2 more examples. We're going to look at some more examples of these sum and difference of perfect cubes. So we'll look at this one here. We want to factor negative 16x to the fifth minus 250x squared. Well, looking at these two here, we're not going to be able, these are not going to be perfect cubes. I can't take the cubed root of x to the fifth. It doesn't have sets of 3. So there is a greatest common factor. One of them being is going to be x squared. Now, if we look at these two numbers here, well, I notice the 16 is negative, yes? So I'm going to factor out a negative. It works out actually negative 2. Because negative 2 will divide into both, or factor out of both, negative 16x to the fifth and negative 250x squared. So it works out for this here. The greatest common factor is going to be negative 2x squared. Well, negative 16 divided by negative 2, or negative 16 when I factor negative 2 out, I'd be left with positive 8. Then we'd have x to the third. Now, negative 250x squared divided by negative 2x squared, or negative 250 divided by negative 2, well, a negative and negative would make a positive. 250 divided by 2 would be 125. And x squared factored out of x squared would leave us with just 125. Now let's check to see if we can take the cubed root of it. Cubed root of 8x cubed. And the cubed root of 125. Well, the cubed root of 8x cubed, the cubed root of 8 would be 2. The cubed root of x to the third would be x. The cubed root of 125 is 5. So, the first thing we need to do once we get this set up is our signs. The signs are going to be the same, opposite, always end on a positive note. So since this is positive, our first sign would be the same, so it'd be positive. Opposite would be negative, and we always end this on a positive note. Now we can plug in our a, our 2x. So we'd have 2x. Here we'd have 2x to the second, and then we would have 2x to the first. And then the last one would really have 2x to the 0, and anything to the 0 power is 1, so we don't write it in. Any questions on this so far? Now we need to plug in the b value, which is 5. So we'd have 5. We wouldn't have anything in this spot. The middle spot, we would have 5 to the first, or just 5. In the last spot, we would have 5 squared. Any questions on any of this here? Any questions on any of this here so far? There is a problem with it. There's one thing that's missing from that section here. Does anybody know what's missing from this part here? We still need that greatest common factor. That greatest common factor has got to come down with it. So when we finish writing this out, so let's simplify it. Let's simplify this down. Well, what's going to come first is our negative 2x squared. Parentheses, then our 2x plus 5 times. Well, 2x squared, 2 squared would be 4x squared. 2 times 5 would be 10x. And 5 squared is going to be 25. So on these here, you've got to remember to have that greatest common factor in your answer. Any questions on this here? Any other questions over the sum or difference of perfect cubes? Are we good with these here? Yes? No? Do we want to look at another one? Yes? Which one of these two do we want to look at? Number 4 or number 5? Which one do y'all want to see work? Or do we want to work together? We can work number 5. Now, if I look at these two terms, is there a greatest common factor between them? Is there a greatest common factor between 6z to the 5th and negative 750z squared? Z squared, I would say 6. Because 6 will work. Now, one of the main reasons I know 6 is, well, can I take the cubed root of 6? Is there a number times itself 3 times that is 6? Well, 1 cubed, well, 1 times 1 times 1 is still 1, yes? 2 times 2 is 4, times 2 is 8. So 6 doesn't work. 6 is not going to be a perfect cube because the smallest perfect cube that we can have besides 1 is 8. It doesn't work. So if we factor this out, well, 6z squared out of 6z to the 5th leaves me with z to the 3rd. Minus, well, 750 divided by 6 is 125. And since I factored out the z squared, we just have 125 left over. Any questions on this here? Okay. So we'll have our 2 sets of parentheses, 3 spaces in the first, 5 spaces in the second. Now we need to find the signs. Well, the signs are the same, opposite, always end on a positive note. Since our starting sign was negative, the same would mean we'd have a negative. Opposite would be positive. Always ended on a positive note, so positive again. So for this one here, we'd have negative, positive, positive. Now we need our a and b term. Well, to get the a term, really we're taking the cubed root of not x. It would be z to the 3rd. Well, the cubed root of z to the 3rd is z. So our a terms would be z z squared and z. Our b term will come from the cubed root of 125. Well, the cubed root of 125 is 5. So in the spots where b shows up, we'd have 5, 5 in the middle, and then 5 squared. And when we simplify this here, we're going to get 6z squared times z minus 5 times z squared plus 5z plus 25. And that's it. And that's it. Any questions on any of this here? Any question on anything we've done so far? Are we good with these here? We good with sum and difference of perfect cubes? We understand how this works? Yes? Okay. The last thing we're going to look at for this here and for today is factoring by grouping, or really we can call this greatest common factor twice. That's really what grouping is. Factoring by grouping is greatest common factor twice. Now, when we do this here, we're not going to look for a greatest common factor across all 4 of these, because there's not a greatest common factor between z cubed, 5z squared, negative 4z, and negative 20. There's not a greatest common factor across all 4. So what I'm going to look at first is just the first 2. Z cubed plus 5z squared. Is there a greatest common factor between these 2 here? Well, yes. The greatest common factor between these 2 here is z squared. And if I factor that out, I factor z squared out of z to the third, I'm left with z. Z squared out of 5z is going to be plus 5. So that's half of the first set of greatest common factor. Now we're going to look at the other 2. So we looked at the first 2 and we found a greatest common factor of z plus 5. Or z squared, not z plus 5. Z squared. Now when I look at these 2 here, well, these 2 here have a greatest common factor of negative 4. Negative 4 will go into both of them, yes? Now if I factor negative 4 out of negative 4z, I'm left with what? Positive z, yes? Negative 4 out of negative 20 factored out of negative 20. Well, the negative and negative to make a positive. 20 divided by 4 would give me 5, yes? Do y'all notice something between these 2 terms now? Do they have something in common? There's a z plus 5 in common with both of these here, yes? We can factor it out. I can factor z plus 5 out of both of these here. Well, if I factor it out of my first term, what am I left with? Z squared. If I factor it out of the second term, I'm left with negative 4. That's why I really call this greatest common factor twice, because we did it once. Well, you could say 3 times, but I consider this once. We did it once to here, then we did it twice. So we factor something out of both, and then we factor that what's in common again out of both of these here. Any questions on how we got to this here? Is this factored completely? Well, when I look at this here, the degree of this here is 2. If this will factor, we need to factor it. Well, z squared minus 4, isn't that a difference of perfect squares? It is. So what we have to do is we do have to factor this. Since 4 is negative, the signs are opposite. Our factors of z squared would be z and z. And what would be the factors of 4 that we would use? 1, 2. Now we are done. Because the degree of each one of these is 1, we have factored it as far as it'll go. So especially on big ideas math, they're going to want you to factor this as far as possible. Because it's going to count, if you type this in, it's going to count it wrong because it said in the directions it wanted it factored completely. It's wanting it factored all the way down. This here is factored completely. Any questions on this here? Any questions on anything we've done so far? Okay. Let's look at another one. Now that we kind of have an idea of what we're doing and kind of how this works, I'm going to point out something that's going to be nice. So again, we're going to do the same thing. We're going to look at these first two, x cubed minus 2x squared. Here it's a little bit easier to see what the greatest common factor between these two terms are. And that factor would be x squared. That's the biggest term that's common in both, yes? X squared factored out of x cubed would leave me with x. X squared factored out of negative 2x squared would be negative 2. Any questions on this here? Any questions on what we just did? Are we good with this here? Yes? Now let's look at the next one, negative 9x plus 18. So for me to be able to do the second set of greatest common factors or to factor something out, second, I need both of these terms to have an x minus 2. Yes? Because once our last one we got down to here, the two sets of parentheses matched, so I factored it out. I can use this here to figure out what I need to factor because they need to match. So I can figure out how to make a match. So I need this first term to be just x, yes? What would I need to factor out of negative 9x to make it positive x? Negative 9. Well, if I factor it out of 18, I get negative 2, don't I? So once I do one of them, I see, can I make the other one match? If I can, that's what we'll do. So we can almost use the first one as a roadmap to see what we need to do to the second one. Now at this point, again, we can factor the x minus 2 out of both. And if we do that, x squared, or x minus 2 factored out of x squared times x minus 2 leaves us with x squared. X squared factored out of our negative 9 times x minus 2. But we end up getting x minus 2 times x squared minus 9, and we factor out this x minus 2 from both. Any questions on this here? We're good with this here so far? Is this completely factored? Well, this one here, I can say yes, x minus 2, that's completely factored because the degree is 1, yes? How about x squared minus 9? Well, that degree is 2, isn't it? And this here is actually a difference of perfect squares. So this here will factor. The signs are going to be opposite. Factors of x squared are going to be x and x. Factors of 9 would be 3 and 3. And this is it here. Now, we didn't check the last one, but we can check these and go x times negative 3, negative 3x. 3 times x would be plus 3x, which gives us 0x or 0 like we want. So this does factor. Questions here on grouping. Now, will grouping work every time? Does factoring work every time? Last chapter, were we able to factor every single thing? Well, no. Grouping won't always work. But if it does, it's nice. It helps us be able to solve these faster. It's not always going to work. If we need to do another example, we'll look at number 6. I want to look at number 7. I want to look at problem number 7. Now, when we look at this here, again, I'm going to look at the first two terms first. Our 3y squared, not y squared. Let's try this again. 3y cubed plus y squared. What is the greatest common factor between these two here? It would be the y squared, and I'd factor it out, which will leave us with 3y plus what? 1. Whenever something factors out completely, everything is factored out, it is always 1. It always simplifies to 1. It will not be 0. So now I need to see what would I factor out of 9y to get to 3y. What would we factor out? I would factor out a 3. Because 9 divided by 3 would be 3y plus what? 1. Any questions on any of this here so far? We like this here for the most part. Now we just need to factor out the 3y plus 1 because it's in common in both. So if I factor it out of our first term here, the y squared times 3y plus 1, I'm left with y squared. When I factor it out of the second term, 3 times 3y plus 1, I'm left with plus 3. Any questions on how we got to this point here? Is this factored completely? Can we so 3y plus 1, the degree is 1, so we're good there. Y squared plus 3. Can we factor this? That's the question, isn't it? And we can try factoring it, but let's use a little trick. Let's use this here. This here is an equation that'll help us factor. Or not factor in general, it'll help us determine, is it factorable? Because this here, what equation did this come from? This comes from the quadratic formula. Because negative b plus or minus the square root of b squared minus 4ac all over 2a. And what it works out is that if this is a whole number, what comes out of the square root is a whole number, then our answer is either going to be a whole number or a fraction. It's going to be one or the other. If this comes out to be a non-repeating, non-terminating decimal or an imaginary number, it won't factor. So this here's a kind of a quick shortcut to see, will it factor, instead of actually going through the process of factoring it. Now, when I look at this here, I notice I don't have a middle term. I don't have a y, a number with y. So that means my value of b would be 0. So if I plug it in for this problem, we're really saying 0 squared minus 4 times a times c, which is 1 and 3. Square root of 0, or well, 0 squared is still 0, yes? So really what I have is the square root of negative 4 times 3, which is negative 12. Well, square root of negative 12, the negative comes out as I. And it works out the square root of 12 is 2 square root of 3. Is this a whole number? Is it a whole real number? No. So what does that mean about this y squared plus 3? It's not factorable. It's not factorable. So that's the answer. So on some of them, if you're trying to factor and try to see if it's factorable, this is kind of a shortcut. Square root of b squared minus 4ac will tell you yes or no. It won't tell you what the factors are, but it'll either give you a hint is either yes, it is factorable, or no, it's not. Because if you get anything with radicals or I, it's not. It's not going to be factorable. Questions on this here? And that's it. That is it.